Hello, everybody. Welcome. I'm going to be doing a help video for homework. That is Factoring Quadratic Trinomials, Part 2, 8 from Lesson 8.6. So we did Part 1 before, and in that one we factored trinomials, which are these three-part expressions. And these three-part expressions um, on the last assignment, part one, did not have any number in front, and it was a very quick process. All you needed to do was write a little X thing, and you put the end number on top, and you put the what do you call that? You put the middle number on the bottom. Sorry, and then afterwards you would figure out what multiply to make the top and add it to make the bottom, and boom, you got your answer. We're going to be doing a little bit of that here, except the problems will have numbers in front of the first term here, which does make a difference. We're going to see a couple kinds of problems. So the first kind looks like this one right here, number one. It says 2x squared, 22x plus 48. So let me write that guy down. So 2x squared, 22x, 48. Now here's the deal. If there's a number in front, the first thing you should do, I guess in any problem, is always to check if you can divide something out. Like in this case, 48 and 22 and 2, those are all divisible by 2. So I'm allowed to rewrite this as 2, parentheses x squared, 11x, and 24. Notice I divided each number inside by 2, and the leftovers were x squared, 11x, and 24. That 2 up front is important. We're going to keep that. That's going to be part of the answer. Now, what happened is this three-part thing is like what we had on part 1, or what you would do if there was no number in front. Like the 2 is outside the parentheses, that doesn't really count as in front of the x squared term for the time being. So what that means is I'm allowed to write a big X, put a 24 on top and 11 on bottom, and think to myself, what multiplies to make 24 but adds up to make 11? That would be 3 times 8. And that will allow me to rewrite the answer as x plus 3 and x plus 8. Now, the 2 that I took out front, still out front. So that's my full final answer here. So 2, x plus 3, x plus 8. Somebody asked this. I don't think I mentioned this in an earlier video. You can write this reverse. If you write x plus 8 and x plus 3, there's not going to be a problem. It's totally fine. Okay, another problem. So I look at it and I say to myself, can I divide something out first? Yes, in this case, 4 and 24 and 64 are all divisible by 4. So I'm allowed to write 4, x squared, 6x, and minus 16. Those are what I get when I divide 4 out of those things. And then again, like the last problem, I'm allowed to write a big X, put negative 16 on top, negative 6 on bottom. And what multiplies to make negative 16 but adds up to make 6? That would be an 8 times 2 situation with a negative on the 8. So my final answer will be 4 out front, x minus 8, x plus 2. So be on the lookout. There's definitely going to be, the same kind of problems on your assignment where you can divide something out at the beginning. I hope if you're watching this video, you've already done some of this, because at the point at which I'm recording it, it's what is this, a Wednesday? It's a Wednesday, and it's not due till Monday, so it's a few days and the weekend. But this was assigned 2 weeks ago at this point, so I hope in the last 2 weeks you've taken a look at this in some degree. There will be a test on it prior to this assignment's due date, so it'd be very wise to practice it. And if you're looking at this video, I'm assuming you're practicing it. If I could guess, the people that will not do well are probably people that wouldn't watch the videos anyways. All right, this one, I cannot divide a number out. There's a 3 out front, and 2x and 5. I can't divide any of those things by a common number like I could on 1 and 2. So there's a different process that you got to attend to here. First, the 3 stays where it is. And I'm going to write an x, because we're going to do that. However, the x doesn't just have negative 5 on top. Actually, all along, we haven't been doing just the last number, but we've really been doing the first times the last number. On the last 2 problems, the first number was technically 1, so it didn't really count. Here it counts as negative 15, and the bottom's a negative 2. The 2 numbers that make this work is negative 5 times 3, that makes negative 15, and adds up to negative 2. Okay, now from here, you have some choices. You can either do a method called the bottoms up method, or you can do a method called the box method. It's your choice. I will show you both right here and let you decide what you be interested in doing. If you do the box method, you make a 2 by 2 box, hopefully not that slanty, and you write the following things inside. You write 3x squared and minus 5, the same two things that shared an arrow earlier, but instead of writing negative 2x, you're going to split that into these two new numbers you found on the side, the negative 5 and the positive 3. So negative 5x, positive 3x, and then the process you go through here is you decide what you can divide out of each row and column. So first row, those are both divisible by an x. Second row, those are only divisible by a 1. There's nothing else that goes into that. First column divisible by 3x, and second column divisible by negative 5. Notice that when both things are negative, I can take out a negative. This is a very similar process to an earlier assignment, 8.5, when we were factoring by grouping. So what happens is you get x plus 1, 3x minus 5. That's the solution there. Now before I go crazy and type that in, that's one way. So this arrow represents you doing the box method. This arrow represents the bottoms up method. You write x minus 5, x plus 3, which is very similar to what we have been doing on assignments. Except for this isn't right. This doesn't work. This doesn't make 3x squared minus 2x minus 5. Because, well, it just doesn't. So the way you correct it is you take this number that was out front, the 3, and put that underneath each of these. This is doing, I don't know, some kind of math voodoo. Can't really explain it, but it's working out here. Technically, by multiplying the 3 to 5, you've kind of messed something up, and by dividing everything by 3, it's fixing it. I don't know how to describe it exactly, but it works. Now here's the deal about this. If the number you're dividing 3 by cannot divide by 3, you bring it up in front of the x. So this actually becomes a 3x minus 5. So the 3 goes with the x, and the minus 5 is the minus 5. If it can divide by 3, like in the second one's case, you get 1. And you'll notice that's the same exact answer as what I got using the box method. I mean, I got them in reverse order, but it doesn't really matter which order you get it in. You get the same answer either way. So I guess it's really up to you what you like doing more. So if you like writing the two parentheses, kind of akin to the problems without the number out front, and then kind of correcting it by dividing them by the number that was out front, you totally can. Or if you wish to write a 4-piece box using the first and last terms, and the two terms you split it and do a factoring by grouping kind of method way, that's fine too. They're both good methods. Now I'm totally not going to waste that much time explaining the rest of the problems. If there was one problem you watched on this explanation, I hope it was that one right there. All right, let's go for some more. So we got two. Oops, let me make it black again. I was color coding just to show my two different methods. 2y minus 15y plus 7. Okay, so I do outers. No matter what method you choose, you got to use this. You got to do 14 over negative 15. And the things that multiply to make 14, but add up to 15 are negative 14 times negative 1. So from here, it's your choice. How about this? I'll do a couple problems with bottoms up, and I'll do a couple problems with the box. So I will write y minus 14, y minus 1. I'll put each of those over 2. This is the bottoms up method. Y minus 7 is what you get from the first guy. And on the second guy, you can't divide by 2. So you'll move it up in front of y and write 2y minus 1. Oh man, now that you've seen this, if you're following along here, when I do the box method later, it'll seem like a much slower process. I mean, I ain't gonna lie to you, it is a little bit slower. But I'd say it's a safer thing to do. You're more likely to get some kind of mistake on the bottoms up quote unquote method. All right, so this makes negative 21 minus 4. The two numbers that make that work are negative 7 times 3. Ironically, those were the numbers that multiplied to make 21 in the first place. That's not always the case, but I can point out that does make a unique answer, like x plus 1 or x minus 1 tends to be something that shows up in the answer. Let's see if that happens here, and I'm right. So I get z minus 7, z plus 3. Both of those go over 7. Oh, I can see it now. Z minus 1 shows up, as predicted. And the 7 goes here and makes 7z plus 3, because you can't divide 3 by 7. One thing I should mention about this bottoms-up way is if you if you get a fraction that can't divide but can reduce, you have to actually do that. So like on my case, 3/7 it can be reduced, but if I had 3/6, I would have had to turn it into 1/2, then do the bottom up. So it is a little extra step you'd have to take that you would otherwise skip if you did it the box method, I think. Yeah, that's what I want to say about that. All right, let's do this one with the box method. One thing I should mention, though, looking at this problem reminded me to tell you something. Always on these problems, always when factoring, always when thinking about factoring, you should always check if you could divide something out. I apologize. On the last two problems, I should have mentioned that I definitely couldn't factor anything out. Here, I thought of it because I saw 3 and I saw 30 and went, ooh, that looks divisible by 3. But then 19 is not divisible by 3, so it's kind of ruined. So here we go. We're going to do 3 times 30. That's a 90. Pretty big number on this one. And adds up to negative 19. Negative 10 times negative 9. It may take you some searching to figure that one out, but it's possible. You might have to guess and check. Use your calculator, so on and so forth. 3y squared and 30 from the original problem go in the box. Negative 10y and negative 9y go in here. It doesn't really matter what order these two things you split go into. First row, I can divide by 3y. Second row, I can divide by 10. First column, I can only divide by y. And second column, I can divide by 3. Now, the box method has one important factor you have to think about. And that's the fact that you could check to make sure these outsides make the insides. You can't really check like that using the bottoms up method. Does 3y times 3 make negative 9y? Actually, no. It makes positive 9y. So something's wrong here. Actually, a sign is wrong. Now, the bottoms up method kind of accounts for the signs already because see how this is negative and 10 is negative and 9 is negative, which would tell me that the two terms I want have a minus sign in them on the second thing. You never have a minus sign on the first thing, really. That being said, I'm going to put two negatives on here because negative 3 makes this work out. That's why I'm saying the box method's good. You can see that it works out, and y times negative 10 works out. Also, if I make both negative, two negatives multiply to make a positive 30 in the corner there. So my final answer, 3y minus 10, y minus 3. There's my answers there. Okay, that felt longer, but that was probably because I was explaining things. I only recommend this method a little bit. I slightly recommend it more because when you're factoring a 4-piece term, you have to do it by grouping, which requires use of this. It doesn't require use of this box, but is helped by the use of this box. And I'd like you to be able to apply it to as many problems as you can. If you are a fan of the bottoms-up way, you can do it. All right, so I get 14 times negative 3, which is negative 42, and 11 on the bottom. And shockingly, 42 is made by doing negative 14, no, positive 14 times negative 3, right? Let me erase that plus sign. It's kind of gross where it is. Okay. So anyways, 14 and negative 3 make negative 42, and also 14 and negative 3 adds up to make 11, so the perfect numbers are there. So in that scenario, just telling you, if the same numbers that crossed are the same numbers that end up working, there's probably going to be x plus 1 as part of the answers. Hey, let's confirm that's true, so go with the box. Oh, that is the sloppiest I've ever written one of those. Yikes. All right, 14z squared, 14z, negative 3z, and negative 3. Notice the oh my goodness. The diagonal corners were made from, okay, you know what? I'm not even going to try and fix the box at this point. Made by me putting the things that I split. 14z comes out of the first row. Negative 3 comes out of the second row because they're both negative. That's why I chose negative already. Z comes out of this first column, and only 1 can come out of the second column. So 14z minus, my handwriting's getting terrible, 14z minus 3, z plus 1. Sorry, that was like so sloppy in the handwriting there. 14z minus 3, z plus 1. You ever wonder if Alex would like mark you wrong if you forgot the last, what do you call it, the last parenthesis? I don't think it would, right? All right. So now we're going to do another one. Now, I'm going to be honest. I didn't put this on the test. If you're struggling with this problem, I hope you look at this. There's a negative in front of the first term. We haven't experienced problems with a negative in front of the first term. I am going to say this. You're allowed to take the negative outside of a parenthesis, but the cost is everything has to flip its sign. So this negative 7 becomes a positive 7 inside. The negative 18 u becomes a regular 18u, and the plus 9 becomes a minus 9. So what that means is at the end of the problem, we're going to have a minus outside the parentheses. Otherwise, we just do what we normally do. Now, here's the deal. I think if you keep it in there and you still do the usual steps, you still get the right answer. Should work out. I'm just saying this is a safe method, and I would recommend it. So let's cross this. Negative 63. 18. What multiplies to make negative 63 but adds up to 18? Well, it ain't 7 times 9. That would only add up to 16, huh? So here's what you want to look out for in these types of situations. Notice the top is negative and the bottom is positive. That means I have two different signs. The only way to make a negative number is with one positive thing times some negative thing. And those particular numbers are 18 away from each other. Now, I'm just saying that because it's going to take some guessing and checking. Like there's a few combinations that make 63. 1 times 63, 3 times 21. Oh wait, I lied. There's not a lot of combinations that make that. 7 times 9. Is that it? Yeah, I think that's it. Okay, so I got 3 and 21 because that makes 18 if I do minus on the 3. All right, I'm going to use bottoms up on this one. So I'm going to do u minus 3, u minus 21. Put them each over 7. Can't reduce that one, so it becomes 7u minus 3. And the second guy can divide, so it becomes minus 3. Oh, wait, plus 3. Sorry, that's a plus 21. Got to be careful there. Any wrong sign is wrong, you know. Speaking of not wrong signs, that minus I took out at the beginning, it's still here all along to the end. So my full correct, hopefully, final answer is negative, parenthesis, 7u minus 3, u plus 3. Nice. All right, this one has x and y. I'm not planning on putting this on the test, but it's totally something you could encounter in math. So let me write it out, I guess. I mostly just don't want to write the problem out because I'm lazy, but I'll write it. So I'm still doing the normal stuff. Still 4 times negative 18. That is negative 72 and 21. And these are pretty big numbers, but after some soul searching, you'll get negative 3 times 24. And I will bottoms up here. So x minus 3. Now here's where the difference comes in. X minus 3y. X plus 24y. You're going to append a y at the end of each of these because that will satisfy how do you get y, xy in the middle, and y squared at the end. That's just how it is. You just have to know. If I see two kinds of letters in this kind of structure, x squared, x, y, y squared, you're going to need x on the first bit of each binomial you make and y on the second bit of each binomial. Now, I'm not done because this doesn't make 18. I need to do the bottoms up thing. So I'm going to put this over 4. Put this other thing over 4. I can't divide by 4, so I get 4x minus 3y. That's a spicy binomial right there. And on the second one, I get x plus 6y. So 4x minus 3y, x plus 6y. These were fun problems. They didn't take any time at all. Actually, honestly, I thought this would take about 30 minutes. It will take about 25 probably by the time I wrap up this last problem. All right, last problem. Same as a previous one. So 2x squared minus 3xy minus 27y squared. I'll do this one with the box. So I'm going to put this x here. 2 times negative 27 is negative 54. What multiplies to make negative 54 but adds up to 3? 6 times negative 9 makes 54, and 6 minus 9 makes negative 3. Yes, if you're thinking to yourself, oh my gosh, he's so fast at figuring that out. Well, I have no advice on how to increase your skill on that other than by saying It really just comes down to how well you know multiplication facts, and then not guessing, but like figuring out like stuff that makes reasonable sense to me. In my scenario, I've kind of done this a bunch of years. Notice when I'm writing this in the box, I'm using x, y, and y squared as the term. So that will help remember to put y on the second terms because you're rewriting the original expression with y's in it. So I guess the box here is kind of nice. First one, I can take out 2 and x. Second row, I can take out -9 and y, because they each have a y in it. First column, I can only take out x. Second column, I can divide by 3y. Yes, and confirm it. Does -9y times 3y make -27y squared? Yes. Does 2x times 3y make 6xy? Yes. So actually, things are working out real nice here. I feel like the box definitely helps you see the big picture on this kind of problem a little better than the bottoms up way. But it's doable either way, so it's really kind of up to you. If you've been watching this whole thing going, I can't decide which way I like, I don't know, start doing a problem, and when you get to the point where you got to decide, don't even think about it. Just start writing it, and maybe you'll, at that point in time, say, okay, this is what I felt like writing, so this is probably the method I like better. All right, that's a doozy of an assignment. I ain't gonna lie to you. Factoring quadratic trinomials with numbers in front of the first term is not meant to be some kind of easy 30-second type of problem. Sorry. If they gave me 20 of those to do, it would take me 20 minutes to do because I gotta spend a minute doing it, especially if I'm writing it down. I mean, and this is the kind of thing you have to write down. It takes time. Okay. That being said, I do realize that how much time it does take, and it took me 20 minutes explaining it to you to do these problems. So on the test, don't expect tons of them, but do expect good amounts of these. On my test, on if you're taking an AZ Merit, you're taking an ACT, they're going to put one of these on the ACT. Can you factor one of these things? They want to make sure you know how to answer that to get entry to college. Well, in terms of math skills required to get into college. There you go. That's 8.6, part 2. I appreciate you watching it if you did, and I'll see you on the next one. Goodbye.